Okay, we're going to look at another net change problem. This one's actually going to be easier than the marginal cost one. Let's go ahead and read this together. It says water flows into a tank at a rate of R of T equals 3 plus 4T gallons per minute. I want to go ahead and just kind of show you a picture. Here's my little spout I'm going to draw. Okay, and water is dripping out of this thing. Oh, that's not going to be a good water droplet. Let's try this again. Okay, so it's going to look something like that, right? That is going to be flowing at a rate of 3 plus 4T gallons per minute. So let's just plug in 1 for time. That would be minutes since it says gallons per minute. So at 1 minute, this would be flowing out at a rate of 7 gallons per minute. After 2 minutes, plug in that, would be 11. It would be 11 gallons per minute. As we increase time, the water is going to be coming out of the tank faster and faster and faster. At time 0, it's going to be coming out at 3 gallons per minute. So it's going to be increasing by 4 gallons per minute every minute for the rate. How much water is in the tank after 1 hour? They're giving us a rate of change function, gallons per minute, and we need to answer a question about how much water is in the tank. This is a net change problem. Again, when you're given the derivative, and in order to figure out the original, which is in a rate, it's just rate of water, not rate of water, you would use net change. And remember that the definite integral of the rate problem gives you the net change. Pretty cool. And take a look. Step 1 is to write out the general formula for net change. In this case, if we integrate the flow rate of water from A to B, or from A to B time, we get the change in volume of water. Okay. Now again, this is net change. Later on, we will talk about total. Step 2, determine the limits of integration. Now, sometimes, I should say, sometimes net and total change are the same, especially if your rate function and your original function are both positive, then you won't have to worry about absolute value for total change. So in this particular problem, I don't believe there's ever going to be a negative amount of water in the tank, so you won't have to worry about that. Step 2, determine the limits of integration. So we're going from 0 to 60 because it says after 1 hour. In fact, I will go ahead and kind of underline that or underscore that because this is in terms of minutes, your rate formula, but it's saying after 1 hour. So that means you have to be going from 0 to 60 minutes. So we want to figure out how much water is in the tank after 1 hour. Pretty cool problem. You can't just plug in 1 and say, well, there's 7 gallons in the tank. No, that's the flow rate. Okay, so, you can imagine someone sitting here with their hand just slowly opening the valve and filling the tank up faster and faster as time goes on. If this went on forever, you could see it's unrestrained. After 100 minutes, the flow rate would be 403 gallons per minute, which is just insane. But anyway, we're just going to limit it to after the first hour. I do want to say one more thing, actually. If you take the derivative of the rate change, or the gallons per minute, you get acceleration. So that tells you that the rate isn't speeding up. In fact, acceleration would be 4, just be the derivative of gallons per minute. The water does continue to increase in speed going into that tank. So how much water is in there after 1 hour? Step 3 is going to be to determine the rate function, which they gave you, R of t equals 3 plus 4t. Step 4 is to determine the definite integral. That gives you the net change if you take the integral of the rate of change. So we're just going to integrate 3 plus 4t from 0 to 60. Again, that represents after 1 hour and 60 minutes. We're going to use the reverse power rule for antiderivatives, 3t plus 4t squared over 2. That simplifies to 3t plus 2t squared. We're going to plug in 60 and then subtract the lower limit. However, when you plug in 0, you get 0 back. Makes sense. There's not any water in the tank until you start filling it up. So it makes sense that at 0 minutes, there's 0 water. We're just going to focus on the upper since that's 0. We end up getting 180 plus 7,200, which is 7,380. What that means is, again, we want to answer this question verbally. There are 7,380 gallons in the tank after 1 hour. Pretty crazy. That seems like a whole lot of water. And in fact, it is a lot of water. That's getting close to like a tank that would supply a small town, like a water tank. And it's kind of crazy too because you think, okay, well, after 1 minute, it's only flowing 7 gallons per minute. So it just seems like a really big number. However, this is after 1 hour. Okay. So after 1 hour, in other words, 60 minutes, this rate's going to keep going up and up and up and up. You can see if you wanted to figure out the rate at 60, just plug in 60 here, you get 243. So after an hour, this is coming out 243 gallons per minute. That's a lot of water. So from 0 to 60, you can imagine it's going to add up pretty quick as that rate increases. That's it for this question. If you have any other questions about it, let me know.